Hey there, welcome back. So I'm going to be very, very honest with you, very upfront. The topic that we cover in this section, dynamic programming, is a little notoriously hard to learn, and also equally tough to teach. I can attest to that definitely. It's a huge topic. This is going to be a light introduction. We're not skimming over anything important, but we could I couldn't, but there could be there are entire books written on dynamic programming algorithms. This is just going to show you the basics, but it's still not the easiest thing on earth. But don't be scared. I might be a little bit. I'm just kidding. I've taught it a couple times, and every time it gets better, but it's still one of those topics that I feel like it could always be improved. My lectures could get better. So I don't know, leave some feedback if you have something. The one thing I do want to say, in order to get anything out of this section, you really need to be, you don't have to be confident, but comfortable enough with recursion. The problems we're going to start off with aren't crazy complicated, but you need to be able to understand what recursion is, take a look at one of my recursive solutions I'm going to show you, and sort of step through how it works. So if you skipped any of the content on recursion here, that's going to make things a little bit tougher. Okay, so let's start with our simple objectives. Of course, we want to talk about what dynamic programming is, and then there's two terms we have to define: overlapping subproblems and optimal substructure. So these are two conditions for where we could use, they're two indicators that we could use dynamic programming on a given problem. So we'll come back to them. They have their own videos. And then we want to solve some more complicated problems. Nothing earth-shatteringly tough, but we want to solve some problems with dynamic programming. And this last one gives us a hint as to what dynamic programming is. We can use it to solve problems, some problems. So here's an actual definition. It's a method for solving a complex problem by breaking it down into a collection of simpler subproblems, solving each of those subproblems just once and storing their solutions. So it sounds a little crazy, but to put it simply, it is an approach for solving some problems. Most problems cannot be solved with it. It's a pretty small subset, but the ones that can be solved with dynamic programming, it can make a huge difference in their performance. Sort of like when we talked about divide and conquer earlier in the course. That is an approach for solving some problems. It doesn't apply to most, but when you can use it, you can really speed up your code. So we're going to return to this definition. I don't expect it to make much sense at this point, but the key takeaways are it is an approach or a pattern for solving a problem where we take that problem and break it into smaller pieces. And then we reduce duplication of those smaller pieces by remembering them or storing them somehow. But we'll come back to all of that. What I want to start with now, to wrap this video up, is a bit of a point of pain in my experience in teaching this topic. The name, dynamic programming. It sounds like something that it's honestly not. It sounds like when I say dynamic programming meaning code or writing, programming a computer, dynamic sounds like we write code that does different things or that has different sort of varying outputs or somehow is changing. That's not really the case. In fact, the name dynamic programming was coined back in the 1940s by this guy, Richard Bellman, to describe something that had nothing to do with computers or computer programming or computer science. I believe it was referring to optimizing military schedules. And there's this long quote that he has that explains it here. But essentially, the two terms, dynamic, was chosen by Bellman to capture the time-varying aspect of the problems, and because it sounded impressive. He thought that dynamic was a good adjective. Actually, he says it was something not even a congressman could object to. So he was trying to come up with a phrase that was pleasing to people so that he would get funding, essentially. And then programming, again, didn't refer to computer programming. It refers to finding an optimal program. In the same way, if you've ever heard the term linear programming, which refers to finding a good outcome, I'm just reading from this, by the way, a good outcome in a mathematical model whose requirements are represented by linear relationships. This has nothing to do with code. Programming has a total different meaning here. So when we put together dynamic and programming, it sounds like something that makes sense in today's modern world around code and ever-changing, fast-paced, crazy algorithms. That's not what it is. What it actually refers to is coming up with an optimal solution, both outside of the code world, just in math in general and planning or making decisions, but then it was also applied into the world of code and programming as we know it, which is what we're going to talk about. But I just want to get that out of the way. The term can be very confusing. It sounds like something it's not. Anyway, that's all I'll say about it for now. In the next video, we're going to talk about one of those scary words that has to do with dynamic programming. Overlapping subproblems.